My talk is called Shopify's Path to Kubernetes. So before I start, I'm just going to quickly go over the outline of the talk. I'm going to start with an introduction about me and Shopify, for those of you who don't know, followed by a history of development at Shopify, why we chose to move to the cloud, and particularly Kubernetes, the guiding principles that we had behind what we actually built and how it kind of works, what we learned from it, and kind of where we're headed towards the end of it. I think there should be some time for questions at the end. So, who am I? My name is Karan, and I currently work as a production engineer on the cloud platform team at Shopify. I'm based out of Ottawa, which is our headquarters. My team is responsible for building and running our internal platform as a service on top of Kubernetes and GKE, which is Google Container Engine. Prior to cloud platform, I also worked on dev tooling at Shopify and also as an app-level developer on both iOS and Ruby on Rails. So for those of you who have never heard of Shopify, Shopify is a commerce platform that allows merchants to sell both online and in person. Shopify was actually started back in 2006, where the main focus was only on e-commerce websites. But over the years, it has kind of grown to not only run e-commerce websites, but also in person and on social media. So if you bought something recently online that was not on Amazon or eBay, chances are that it was actually a Shopify store and you didn't even know it. So where is Shopify in 2018? We currently have 3,000 plus employees spread across Canada, the US, and Europe. We have more than 600,000 merchants using the platform, and they've made more than $55 billion worth of sales on the platform itself. So the goal behind this is not necessarily to show the merchant count, but also how big Shopify is getting as a company internally, and the implications that it has on development at Shopify. Okay. Oh, perfect. Kind of moving on to what does development at Shopify look like? So kind of looking back in 2011, when Shopify was still fairly a small company, we only had about 10 or so services running in production. The most important at the time was our e-commerce monolith, which is also the most important currently, but at the time it was basically the only service we were really focusing on. And we only had about tens of developers working on it. So due to the scale of which Shopify was running our development internally, it was a lot easier to focus on the one business critical application and make sure it was resilient and scaled as and when the company needed. So looking also at the our core monolith, which is the e-commerce websites, was only deployed about less than 3 times a day, which is at the time was fairly manageable with the smaller team we had. Now this relatively looks fairly drastically different in 2018. We went from just having about 10 or 11 services to having more than 400, from tens of developers to hundreds of developers. And the core monolith that was being deployed only about 3 times a day is now deployed more than 50 times a day. And accounting for all the other services that also run at Shopify, this is drastic. It crosses 200 deploys a day depending on the day itself. So the change behind this, what we saw was, as and when we scaled and the business of Shopify kind of grew, the core monolith wasn't the only important application anymore. But because of the way historically development at Shopify was done, it was still the one that got first-class support from our production engineers. And this started to kind of cause issues as we started to scale. So for us, the production environments where we were running our services started to diverge significantly, which made it really hard to kind of share the tooling across anything. So prior to building our cloud platform on top of Kubernetes, we had 3 possible places where you could run a service at Shopify. So the first one was the data center. Secondly, the cloud at the time, which we used AWS. And lastly, Heroku. So kind of going into each of them quickly. Our data centers are co-locations in North America, and we manage all the hardware there. This is where we ran most of our containerized applications, which was the core monolith itself and a handful of other services. So because this is where our entire business critical applications were running, it always had first-class support from our operations and production engineering teams, which kind of led to the best of the tooling being built for our data centers. So moving on to AWS. AWS as a cloud was kind of handled by different teams over the years, which led to not only distinction between AWS and the other production environments, but within AWS itself. An example of this is some of the machines at AWS were provisioned using Chef, some used Terraform, and some were even just hand-rolled. potentially from teams that don't exist anymore. So not only was it starting to diverge within distinct environments, within the same production environment, we still were having issues kind of building tooling around it. And then lastly, we had Heroku. Heroku, in terms of the service count, was by far our largest production environment. Not necessarily for the scale for our merchant base, but in terms of how many services we're running here. Because most of the services at Shopify were much smaller than our core monolith, they approached Heroku like a DevOps. So the team started to make their own decisions into what kind of add-ons they were going to use with it. An example of this would be some people decided to use MySQL, where some people started to diverge by using Postgres or even MongoDB. So the problem we started running into is as we started to try and scale our production engineering organization, which is a pretty small percentage of the rest of the engineering org, we couldn't really scale to build tooling that would support all of the services at Shopify. We didn't have the ability to have another application at Shopify just become the core monolith because it never got the first-class support from the beginning. So this kind of started our exploring into like why we actually chose to build on top of the cloud. So this goes back to 2015 when we started this project. It was around the same time where the safe harbor discussion was also happening. So we were in the process of searching for a third data center, which is going to be in Europe. Internally, we had a hackathon for a couple of days, and a few developers decided to build up a team and see whether we could run our e-commerce monolith, which is entirely Ruby on Rails, on top of the cloud. So the goal behind this wasn't necessarily to see whether it was possible. It was to see what kind of engineering effort it would take to run the core at the scale it needed to run at. So given a few days and kind of experimentation, we managed to get a prototype running. So instead we kind of focused on, instead we paused the data center look and started focusing on building, not only just moving our core application to cloud, but building a platform on top of cloud, which every running service at Shopify could use. And the goal behind this was cloud promises to be easier to scale without having to invest in resources to build up your new data centers and having a team to manage those. And the bigger benefit was the consistency across all applications at Shopify. We could scale production engineers by them focusing on just building common tooling that every service at Shopify could actually use. So this is why we used cloud. Why Kubernetes particularly? So the first one was we had extensive experience using Docker in production. We had been doing it for our core monolith since 2014, and we were fairly comfortable with the ins and outs of running containers at scale. Kind of look at the second one, Kubernetes has and currently also has like a large amount of community support behind it. So companies like Google, Microsoft, and AWS or Amazon don't just support for their own cloud platforms, but instead also focus a lot on contributing back to the open source tooling. Then Kubernetes is based on the idea of sharing resources. So by being able to run a lot of smaller services at Shopify on the same underlying hardware, we get the chance of being able to optimize our resource usage. And then lastly, which was one of the most important decisions for us, was the fact that it was platform agnostic. Kubernetes allows you to run it anywhere and across multiple cloud providers or run it yourself. And we wanted to be very careful of not getting vendor lock-in. So kind of what principles did we use to actually build the platform? So before I get into what we actually built and how it works, we had a few principles that we were really focusing on when we were planning what exactly to build. So the first one, what I call is the paved road. The concept for us was making sure, so for us, the stack that's really essential at Shopify is Ruby on Rails. So for us, it was to make sure that anybody developing a brand new Ruby on Rails application at Shopify could get it running into production in less than in a reasonable amount of time with very little knowledge about how the platform actually worked. So the goal behind this is not everybody is going to use every feature you build into a product. So you want to make sure that the use case that the majority of the users need is first-class supported, but at the same time allow those hooks to be extendable. We didn't want to prevent people from Shopify from choosing the right tool or right programming language for their use case. So we still want to support everything else, but the goal was to make Ruby on Rails really easy and everything else as easy as we could make it, given that the developer might have to have a bit more amount of legwork to actually get it running. So the second was hiding complexity. Kubernetes and containers are great technologies, and we've spent years learning how to use containers in production, and actually spent the last year and a half or a few years running Kubernetes in production. But the goal was we don't want every developer at Shopify to have to drop whatever the features they're working on and spend the next 6 months learning how to write Docker files or learning how to optimize containers to run in production. We want to make sure that we build the right level of abstraction on top of the platform that we're building, so a developer can go and just deploy to production without having to understand the intricacies of either Docker or even Kubernetes. At the same time, you don't want to prevent anybody from learning. The goal is to, if a developer is interested, all of the information is available for them to go and hunt down to see how the underlying infrastructure actually works. And the last is making sure the platform is self-serve. So as I previously mentioned, most of the services at Shopify were running in Heroku. So a lot of the developers were already used to the self-serve mentality. Secondly, production engineering being such a small portion of the engineering organization, we wanted to make sure we could scale as the number of services, the number of developers at Shopify grew, and not necessarily linearly. And the more self-serve the platform is, the less support load we have in the long run, and the more we could personally focus on building the actual platform behind it. So given all of this, what did we end up building? I know there's a bunch of text on this slide and boxes, but the main goal behind this is to understand this is a simplistic overview of what a cluster for us looks like. There's two major parts. One, inside the box is the actual Kubernetes clusters where the applications run. And everything above the box is the actual user interaction part. So for users, it's a much simplistic overview, and all of the complexity, or as much as we could, is abstracted away into the actual platform itself. So just focusing on what the user domain actually looks like and how they interact with the platform. So imagine you just started at Shopify. And your first team project is to build a brand new Ruby on Rails application. You have some familiarity with Ruby, but how do you get it running in production? So first step, you run Rails new, have it set up locally, and then you push it to GitHub. But what next? How do I demand what infrastructure looks like in a self-serve manner? So you use a service or an internal tool we call Services DB. It's just a way for us to track all running services at Shopify. The more important aspect of that is it's actually just a simple web UI, which allows you to pick and choose how your infrastructure needs to be set up. So you created a new GitHub repository, you go to Services DB, and you have the option of creating a new cloud runtime. Right? You go click that button, and I know there's a typo. I mistakenly named the repo for SREcon18, not NA. But so once you actually go and pick that you need to create a new cloud runtime, the first option you get is what stack you need. So this is what I meant by the paved road. The Rails is our default stack, and this is what has the most amount of support behind it. An example of that is we have an internal gem that is a requirement for every Ruby on Rails application to be run on the platform. And it does some common tools like adding a ping endpoint for your health checks, make sure your asset uploading actually works, and so on, and your logging is set up correctly. So invisible to you, we can get your logs into Splunk or wherever they might need to go. But the other option you have is the other stack, which the concept behind it requires more effort to use. But given if there is a proper use case for something beyond Ruby on Rails, we have that option. So once you actually pick the stack you need, you kind of get this menu of what add-ons you need. But these are basically infrastructure elements that you actually want to run in production. So in my case, since I was just building a brand new Ruby on Rails application, you want a web server, you want a MySQL database, in this case it's called SQL, then you want a way to migrate that database on every deploy, and lastly you want asset uploading, so that you can make sure your assets are available on our CDN, and they're super fast to use. So all you need to do after this is click on the giant blue button at the bottom, and this goes back to your GitHub repository. So once you click the add-ons you require, you can go back and edit them if you need, but Services DB creates a pull request against your GitHub repository. So this pull request contains two things. One is a way to manage secrets so that when your application is deployed into production, we can decrypt those secrets and you can use it. And then secondly, and the more important ones, is the actual Kubernetes templates. So currently, the Kubernetes templates are machine generated, but they live in the user's own repository. So the idea behind this is currently, they can make small changes like bumping up the replicas, scaling up or down the resources they require, or the command the container runs. But they don't actually have to understand the majority of the complexity of Kubernetes. So once you merge that repository into GitHub, how do you actually deploy it? This is where another one of our tools comes in. It's called Shipit. It's actually open source for the past 2 years. Shipit is a simple command runner, which we use to actually deploy stuff to production. Prior to Kubernetes, it used Capistrano to deploy our actual core monolith, and also used Heroku deploys for our Heroku applications and so on. So once you go to Shipit, the other thing you need to be able to deploy is containers. And you'll see I actually purposely skipped container builders in this slide because for a new user, containers are done invisible to them. So when you create a new cloud runtime, by default, you get a container builder pipeline, but it actually uses build packs to build you a Docker container. So it will just detect that it's a Ruby application and just use the Ruby Heroku build pack to build the new Docker container with your application files in it. The goal behind this was you want to be able to support people using Docker files if they need to optimize it, but we don't want to expect everybody to actually learn how to use Docker and write Docker files for all of the 400 services just to run here. So once you go to Shipit to actually deploy it, you get this giant wall of text. The important part here is we use a gem that we wrote, which is also open source, called Kubernetes Deploy. So what Kubernetes Deploy actually does is it uses kube control in the backend to simply tell the kube API server what the desired state is and deploy the configs from your GitHub repository. But beyond that, it also monitors the rollout of every deployment, pods, or any of the custom add-ons that we have. The reasoning behind this is historically at Shopify, we always had Shipit where we could go manually deploy as a developer, and we would get a green check mark for a success, or we would get failure and the logs regarding that failure. And given the Kubernetes model of simply just applying your desired state and the API server managing everything else, it isn't conducive to what our developers expected of us. So we had to kind of build this tooling around it to make sure that we conformed to their expectations instead of changing them. So once you have that deployed, you have a running app in production with SSL cert and everything provisioned for you. And this, from start to finish, took me less than 15 minutes. So coming back to how does this actually work, right? It's a much simplistic overview of how the user interacts with it, but there's a lot of complexity that actually goes down into the actual cluster part. So kind of just focusing on it, there's a few tooling around here that I've actually skipped and just stuck to the more interesting aspects of it. So going over the simplest part here, it's a simple HTTP service that we call Grunt Control. It's responsible for creating the private and public key pair that you require for your secrets, but also creating your app's namespace. So every application within the cluster runs in an isolated namespace. The goal behind it is just to make sure that a bad code deployed to an app can't bring down another app. Then looking at the actual app namespace itself, in this case I just called in my app. So it's running 2 web pods and a job pods, which are just simple Kubernetes deployments. The more interesting aspects here are the MySQL, the Redis, and the Cloud Bucket that I showed on the side. Those are just examples of some custom add-ons we have. But because they're custom and not part of core Kubernetes, we had to build tooling around them to make sure they worked the way we wanted them to. This is where an internal framework that we call Cloud Buddies comes in. So Cloud Buddies are just custom Kubernetes controllers. Kubernetes is based around the idea of making sure having controllers drive your current state to whatever your desired state is. And Cloud Buddies are custom Kubernetes controllers that can add on top of the default Kubernetes types. So instead of just having deployments, you can now have a MySQL type, a Redis type, a Memcache type, and so on. So kind of going back as to taking an example of just MySQL database. let's say you go back to a more enterprise-y company and you had to like build a brand new application that needed a database. How would you do it? You might go to your operations team, kind of open up a ticket. Now they're responsible to have to go provision you a machine, be it on cloud or the data center, install MySQL server on it, make sure everything is set up correctly, create you the database, create you the credentials, and then kind of come back to you. Now imagine trying to scale that to 400 plus services, or imagine trying to scale that to 1,000 plus services. It doesn't really work when it's that toil heavy and it's that manual. Now this, in our current platform, kind of looks like this. So it's like 15 lines of a YAML file. A user can go type this in manually if they wanted to, but they don't have to. They can go to Services DB and just pick the MySQL add-on, and this is all generated for them. So the thing with this is it has some basic, as you can see, the client is MySQL, and the API version is actually a Shopify one. So it's a custom type. So when a Kubernetes controller boots up in the cluster, it registers the custom type it's looking for against the API server. And when you deploy this template, be it for an update or a brand new one, the controller is actually able to pick it up and do anything it needs to do around it. So in this case, it picks this up, it provisions you a new Cloud SQL instance, creates you the database you require, creates you the correct version with the database flags you need, with the correct size, also creates a connection URL for you, and the deployments required to connect against your local host, and then it injects them all into your app namespace. So this is all done invisible to you, and it just kind of works. And the really cool part for production engineers or SREs for this is, if you have 400 of these services running, and all of them use this MySQL, and you realize MySQL 5.7 has an issue, or we need a particular database flag to be enabled for every service, now instead of going through every Cloud SQL page and updating it, you can simply just update the loop inside your controller, and now it can actually do it the next time it sees an update for an app. It can just go in and change the common configurations you need. So awesome. You have this brand new tool, platform, whatever. What do you do? Getting buy-in is tough. You can go try the route of just forcing everybody to move and saying, I'm not going to support anything else. But that's not a great way to really build trust in your users. You won't be able to do that if they were your paying customers. So it's hard to even do that for an internal tool. So for us, there were a few things we kind of really focused on. The first one is documentation. It's pretty self-explanatory, and everybody says you need to document everything. But for us, it became super essential. Because we were using this open source tool, but building abstractions on top of it, it hides a bit the complexity, but it also makes it a lot harder to debug. So imagine a user trying to deploy something to a cluster, and it doesn't work. If it was a plain Kubernetes installation, they could grab whatever the error was, kind of Google it or Stack Overflow it, and figure out what was wrong. And if they could fix it, or they come to you. But given how our platform actually works, and they deploy this, they don't know whether it's their application that doesn't work. They don't necessarily know if it's our abstractions don't work, and they don't really necessarily know if it's the Kubernetes underlying that has some issue with it. So for us, having that documentation was extremely important, and kind of it's a continuous focus on it, and it helps a lot in the support load we actually get. Second was actually providing good support. So because the tool is so complex, it was really, really essential for us to be able to provide dedicated support and get proper feedback from users. So the way we actually started this is the platform was used for our internal hackathons a few times, which happened every few months. And instead of our team actually working on their own projects that they were interested in, we're basically around for support through the entire couple of days, and to kind of get feedback from users as to where it was failing, but also be able to kind of handhold them if required. So besides the hackathon, this kind of now changed into having a proper on-call rotation for one of the developers on the team from 9 to 5 during work hours. So the goal was that one developer was responsible for making sure they kind of kept up with our Slack channel, any support requests that were coming in, and so on. So even though we started with that, we've kind of moved on to having a dedicated support person who's primary on call for during work hours throughout the week. And a developer on the team is always the secondary. So the developer's job is just to be there in case extra support need is required or there's something more complex to be done. So why is this important? For us, it does develop empathy for your users because as SREs and production engineers, when we build this production tooling, we have a lot more access than what a developer would have. And we're not necessarily using the same tooling that we're actually providing them because we have access to the underlying tooling to it. So it's really important to be able to develop proper empathy for your users and see what the common pitfalls are, where people are running into issues, what kind of developers are running into issues. Maybe it's not necessarily a Ruby on Rails problem, but everybody who's building a JavaScript application is having the same common problem. So it's really important to track all of these things and kind of go back and be able to look through the stuff that are you actually building what needs to be built alongside what you had to get done. And then the last main thing was teaching. So you get this support request. You have two options. One, you just go debug it, figure out what's wrong, and fix it for them. And then they go back and their job is done, and you can continue whatever you were working on. But in the long run, if they run into the same issue again, or somebody else on the team runs into the same issue, they don't know how to fix it. So it's really, really essential to, if somebody comes to you with a support request, take the extra time to kind of walk them through how to debug. Especially for production engineers, try and make sure you use the tooling that is available to them, not necessarily just you. So in our case, it's like if somebody comes to the issue that they can't figure out why their app isn't running, we could go back to Kube Control, but since not everybody at the company has access to the production infrastructure, we need to make sure we're using the tooling they have. We need to make sure we're using the logging they have access to or the monitoring tools they have access to, and kind of teach them and walk them through how to debug the problem. Another really good way that I think we found was teaching was running a workshop for a set of brand new developers at Shopify who had no preconceived notions of what development at Shopify looked like, and this was basically even before they actually joined their full teams. Their goal was to run through our documentation, which had a walkthrough of building a brand new Ruby on Rails application and deploying it to production. Some of these developers had never even used Ruby on Rails. So the goal was to see, given this step guide, where people faltered. There was a few people from our team actually there for support requests, but also to monitor like where people were running into common issues. Was it the documentation? Was it something in the platform that we weren't aware was actually broken? And kind of track those. But another way that we were kind of surprised that we found this was for the people who kind of finished the entire walkthrough, a lot of them got a lot more excited about it. They were a lot more interested in how the underlying infrastructure worked, and they were a lot more motivated to go back to their teams and kind of jump on the projects where they wanted to migrate the services that were running in either data center or Amazon or anywhere and move them all to the cloud because they were more excited about the technology. So I think being able to teach people how something works and like kind of walking them through it sometimes can build that excitement where they become your cheerleaders and you don't necessarily have to do it. So there's a few main challenges that we kind of focused or that we ran into on migration. Now, because the first two are kind of related, because production engineers mostly only focused on our e-commerce monolith, and which ran in our data centers, we had to get used to not having fine-grained control over our infrastructure anymore. We were so used to running our own network, making sure the machines were the size they needed to be, and so on. It was just something that we had to be very acutely aware of and make sure our monitoring and alerting actually worked given this new environment. So I think the goal behind this is like it's not necessarily a good or a bad thing, but taking on a project where you move to something you might have less control over, it's really important to kind of look and make sure you know what you're kind of stepping into and what the common pitfalls might be. The next one was migration of services took significant effort. So building tooling is not the end goal. Once you have version 1, you can keep iterating on it, but at the same time, you have to make sure everybody else at the company kind of moves on to it. Especially with the tool you're trying to build build consistency around an organization, you have to invest the resources required to migrate everybody off. So for us, it's important to kind of look at when you're making a timeline for your project to know that this is actually something that you would have to focus on. And then lastly, it was kind of a learning process to figure out how we want to educate the developers at Shopify, but also along the side of what level of abstraction we want to build and how much information about the underlying infrastructure we want to give. So kind of what are the main takeaways? First is like build for the paved road, but support other use cases. Most users will never use everything you kind of build into a tool, so make sure the majority use case is very well tested and works as expected, but build extensibility for people or users who are ready to do the legwork in it. Then hide away the complexity. The tooling that we use, like Kubernetes or Docker or any other ones, are extremely interesting and really powerful, but we don't need everybody at a company to actually have to understand it just to be able to deploy a brand new web server. Build a tool to be as self-serve as possible. Kind of make sure like you don't shoot yourself in the foot with the support request you're going to get down the line. Document everything. It's pretty obvious. And then lastly, focus on like teaching people and actually providing support. It's something I think it's worth taking the time while you're actually building it out to see how you can actually do it, given the resources your team might have. So kind of like a quick thing to where we're actually headed. We're currently in the process of moving every running service at Shopify onto the platform. And we're about not only just the smaller services, but the core monolith itself from our data centers to the cloud. We're building end-to-end testing for all our infrastructure, especially the abstraction on top. So the goal is to be able to spin up a brand new application every few minutes, so we're actually able to detect where, if there's any problems with that infrastructure before our users run into it. Easy and fully automated application moves between clusters. It's really essential for failovers, especially when we're trying to build a highly resilient platform. And then better visibility into running infrastructure for an app developer. They don't necessarily have access to the production cluster, so we want to make sure the tooling we provide them to be able to debug any issues with their platform. And that's all I really had. I think there's still a few minutes for questions, but thanks a lot for coming. I'll also be around after if anybody wants to talk.
What do you feel are the major kind of holes in your current setup, and what do you plan to work on next?
Sorry?
What do you plan to work on next?
So currently the main goals are, once we have everybody on the platform, we're working on building, investing a lot in our controllers to make sure we're able to build tooling and be as self-serve as possible. Another thing we want to experiment with is potentially removing more of the complexity out of the Kubernetes templates that the users have to have in their repositories, because they're still very complex and it can be intimidating for developers to go and change those.
How many people did you have working on this full time to build it, and how many people do you have in the team now maintaining it?
So our cloud platform team is, I think, 8 or 9 people. When the project started, there was a separate team that was mostly responsible for making sure we could run our monolith in the cloud, while the rest of the team was kind of focusing on building the platform itself. Awesome. Thank you.